Hello students, welcome to Engineers Academy. Kindly subscribe my channel for the solution of such more problems. Now let's solve this particular problem from Hibbeler Statics. In this problem it is said that determine the force in member BC, HC and HG. So we are required to determine the BC member forces, HC member force and this HG member forces. And in the problem statement further it is said that after the truss is sectioned, use a single equation of equilibrium for the calculation of each force, right? So what does this mean is that we need to write a single equation for BC, HC and HG. We need to have only one unknown in only one equation, right? And further it is said that state if these members are in tension or compression, right? So we will solve this problem by using the method of sections, but before going to apply the method of section, we have to determine the reactions at the supports, right? So first I will find the reaction at point A. Let me draw the reaction. Since at A we have pin joint, so we will have two reactions, right? So let's say that here at joint A we will have one reaction which will be acting vertically upward, and let's say this is AY, and then we will have one reaction which will be acting in this direction. Let's say this is X, right? And at point E, since here we have a roller support, so we will have the reaction in this direction, that is, let's say this is, let's say, E. So now if I apply the summation of moment about point E equals to 0, so then we will be able to find the reaction at point A. But before applying this equation, if I apply the summation of forces along X equals to 0, so as we can see that all the external forces are acting in the Y direction, that is in the vertical direction, right? So if we apply the summation of forces along X, so then this will give us AX is equal to 0, since only the AX force is acting in the positive X direction. If this is my coordinate system, if this is my positive X and this is my positive Y, then AX would be equal to 0. So this means that at A there is no horizontal reaction, right? So now if I apply the summation of moment about point E equals to 0, so as we can see that this AY is producing the clockwise moment about that point E. So I will write minus AY, and the moment arm of this AY from that point E is the summation of all these lengths, right? So this is 5 plus 5 plus 5, so this is 20. So I will multiply this with 20, right? Similarly, this 2 kilonewton force is producing the counterclockwise moment about that point E. So I will write plus, and this is 2, and again the moment arm of this 2 kilonewton force from that point E is the perpendicular distance, and that perpendicular distance is again these 20 meters. So I will multiply this with 20. Similarly, this 4 kilonewton force is again producing the counterclockwise moment, so I will write plus, and this 4 kilonewton force, so I will write 4, and the perpendicular distance of this 4 kilonewton force from that point E is 15 meters. So I will multiply this with 15, that is 4 into 15, and this 4 kilonewton force is also producing the counterclockwise moment, so I will write plus 4, and this is the perpendicular distance is 10 meters, this is multiplied by 10. Similarly, this 5 kilonewton force is again producing the counterclockwise moment, so I will write plus 5, and the perpendicular distance is 5 meters, so I will multiply this with 5. And this 3 kilonewton force and this E, both of these forces are passing through this point E, so they will not produce the moment about this point E, since the moment arm of both of these forces are 0, right? So this will be equal to 0, right? And if I add up all these and divide it by 20, so that will give us EY, right? I bring this EY term to the other side, so we will have the equation like this. This will be 20 AY, right? And if I divide this sum by 20, so that will give us AY, and when we solve it, then AY equals to 8.25 kilonewtons, right? So now we know the reaction at point A. This is 8.25 kilonewton. Let me write it as 8.25 kilonewton. So now I have to pass an imaginary cutting section, and that cutting section needs to pass through these members which we are required to find the force, right? So I will pass an imaginary cutting section like this, and this imaginary cutting section will divide this whole truss into two parts, right? And then for our analysis, we can consider either of these parts, right? So I will consider this part since I know the reaction at point A, right? If I'm going to consider this part, then I have to find the support reaction at this point E, right? So since I know this A support reaction, and here we have lesser number of members towards this side, so I am going to use this this part of this truss, right? So now if I pass a cutting section, then we will have, let me draw the free body diagram of that section that I am going to consider, right? So this is now our free body diagram. This is that point A. Here we have that 2 kilonewton vertical force. Here we have that 4 kilonewton vertical force. This is that point B, and this is that point C. And here we have that point G, and here we have that point H, right? So if I pass a cutting section, then we will have these three forces, right? I am considering this part, right? So we will have this BC member force. Let's say this is FBC, right? This one will be FHC, right? And this one is FHG, right? So remember that instead of FBC, I will write only BC, right? I will write only FHC, and I will write only HG, right? For my simplicity, right? I don't need to write F with BC, HC, and HG every time, right? So now, since we are asked to use a single equation, right? So now if I want to find this BC force, right? So as we can see that this HC force and this HG force, the line affection of both of these forces are passing through this point H. So if I apply the summation of moment about point H equals to 0, so then this HC and this HG, they will not come into our equation, right? Let me write that this is the HC, right? So they will not come into our equation. So if I apply the summation of moment about H, so I will have only BC as an unknown, and in the problem statement it said that after the trusses section, use a single equation of equilibrium for the calculation of each force, right? So now as we can see, if I apply the summation of moment about point H, so this BC is producing the clockwise moment about that point H, so I will write minus BC, and the perpendicular distance of this BC force from that point H is the length of this BH member, and the length of this BH member is 3 meters. So I have to multiply it with 3, right? Similarly, this 8.25 kilonewton force is producing the clockwise moment about that point H as well, so I will write minus 8.25, and the perpendicular distance of this 8.25 kilonewton force from that point H is the length of this EB, which is 5 meters, so I will multiply it with 5. Similarly, this 2 kilonewton force is producing the counterclockwise moment about that point H, so I will write plus 2, and the moment arm of this 2 kilonewton force from that point H is this 5 meters length, so I will multiply it with 5. And similarly, this 4 kilonewton force is passing through that point H, so it will not produce the moment about that point H, right? So this is equal to 0. So now we have single equation for this single force, right? So this single equation will give us one unknown force, that is BC member force, right? So if I add both of these, so this gives me 31.25, right? So this gives me minus 31.25, and this is equal to 0. And if I bring this to the other side of equation, so we will have the equation like this. So from this we get BC equals to minus 10.42 kilonewton, and the minus sign indicates that the assumed direction of BC is not accurate, since we are assuming in that all these three unknown forces are the tension forces, since we have since these three forces are acting from their respective joints, right? acting away from the respective joints, right? But the minus sign indicates that this BC is acting towards this joint B. So if it is acting towards this joint B, so that means that this is the compressive force, right? Now to find Hg force, what we need to do is that we need to apply the summation of moment about point C. We have to select such a point where two forces of these three unknown forces must pass, right? So if you want to find this Hg, then we can observe, we can see that this BC force and this Hc force, they are passing through this point C. So if I apply the summation of moment about point C, so this BC and this Hc, they will not come into our equation, and we will have only this one unknown in our equation, right? So if we apply the summation of moment about point C equals to 0, so as we can see that this Hc is making some angle, right, with the horizontal, right? It is making some angle. Let me draw a horizontal line here. So this Hc is making some angle with the horizontal, and let's say that angle is, let's say that this angle is alpha, right? So now we can find this alpha angle if I draw that horizontal line here, right? So we consider this small triangle, and if I apply tan theta, let's say if this angle is alpha, right? So we can use this triangle, right? So if I apply tan alpha, so tan alpha will be equal to perpendicular, and that perpendicular is 3 meters divided by base. This is the base, which is 5. So if I take tan inverse, so this will give us alpha equals to 30.96. This is 30.96 degrees. So this Hc is making 30.96 degrees with the horizontal, and similarly this Hg is making some angle. Let's say this angle is theta. So now to find this theta, we can use this lower triangle, this triangle, right? So if I apply tan theta, so tan theta will be equal to this perpendicular, which is 2 meters, and the base is again this 5. And if I take tan inverse of 2 by 5, so this gives me 21.80. This is 21.80 degrees. So this G is making 21.80 degrees with the horizontal, right? So now if I want to apply the summation of moment about point C equals to 0, since this BC and this HC, they will not be included in our equation, so we need to resolve this Hg force, right, to apply this condition. So if I resolve this Hg into its components, so it will have two components, right? It will have one component which will be acting in this direction, and it will have one component which will be acting in this direction. And this one is the cos component. This one is, let me write, this is Hg cos of theta, and theta is 21.80, and this one is Hg sine of 21.80. So now if I apply the summation of moment about point C equals to 0, so as we can see that this cos component is producing the counterclockwise moment about this point C, so I will write plus Hg cos of 21.80, and the perpendicular distance of this cos component from this point C is this length, and this length is 3 meters from here, right? This length is 3 meters. So I multiply this with 3. Similarly, this sine component is producing the counterclockwise moment about that point C, so I will write plus, and this is Hg sine of 21.80, and the perpendicular distance or the moment arm of this component from that point C is this length, this BC length, which is 5 meters, right? So I have to multiply it with 5, right? Similarly, this AY reaction is producing the clockwise moment about that point C, so I have to write minus 8.25, and the moment arm of this AY from that point C is 5 plus 5, this is 5 meters, and this is 5 meters, so we have to multiply it with 10. Similarly, this is producing the counterclockwise moment about that point C, so I will write plus 2, and the perpendicular distance of this force from that point C is 10, so I have to multiply it with 10. And similarly, this 4 Newton force is producing the counterclockwise moment about that point C, so I have to write plus 4 and multiply by 5. and this will be equal to 0. So if I take hg common from both of these terms, right, so we will have 3 cos of 21.80 plus 5 sine of 21.80, and if we sum all of these, so this gives me 42.5 minus 42.5, and this will be equal to 0. And if I add both of these using the calculator, so this gives me 4.64, right? So this will be 4.64 hg. And if I bring this to the other side, so I will have 4.64 hg equals to 42.5, and if I divide both sides of the equation by 4.64, so this gives me hg equals to 9.16 kilonewton. And since the sign is positive, so this means that the assumed direction of hg is accurate, that is acting away from this point h. So this means that this is the tension force, right? Now we are left with, we have determined this BC, we have determined this hg, now we are left with this hc. And again we need to write an equation which need to have only this hc as the unknown force, right? So now we have to select a point where the line of action of this BC force and this hg force need to pass, and we have to find the summation of moment about that particular point, right? So for that, let me enlarge this free body diagram, right? We need to have the larger view of this free body diagram. So this is that BC, this is that 4 kilonewton force, right? So now if I extend the line of action of this BC, I need to eliminate this hg and this BC from our equation, right? So if I extend the line of action of this hg, right, let me extend the line of action of this hg like this, right? And if I extend the line of action of this BC, so they will intersect somewhere, and let's say that this intersection point is, let's say, O, right? So now if we apply the summation of moment about this point O, so what will happen is that since this BC force is passing through that point O, and since this hg force, the line of action of both of these forces are passing through that point O, so they will not come into our equation, and we will have only this hc force as an unknown force in our equation, right? So now we have to apply the summation of the moment about point O equals to 0. But before going to apply the summation of moment about point O, we need to find this OA distance, right? Now we need to find this OA distance, since if we apply the summation of moment about that point O, so then this hc is going to produce the moment about that point O, and we need to then we will need to resolve this hc force into its component, right? And this hc force will have two components. It will have one component like this, and it will have one component which will be acting in this direction, that is in the upward direction. This is the cos component of hc now, right? This is hc cos of alpha, and alpha is 30.96, and this one is the sine component of hc. This is hc sine of 30.96, right? So now if I apply the summation of moment about point O equals to 0, so as we can see that this component is producing the counterclockwise moment about that point O. So let me write that summation of moment about point O equals to 0 equation here, right? So this sine component, let me write that hc sine of 30.96 is producing the counterclockwise moment, so I have to write plus, and the perpendicular distance of this sine component from that point O is this length OA plus AB, right? So this is, let me write that the whole distance is OB, let's say, and let me write that OB is equal to the summation of OA plus AB, right? So, and again, if this cos component is producing the counterclockwise moment about that point O as well, so I have to write plus hc cos of 30.96, and the perpendicular distance of this cos component from that point O is the length of this BH member, and the length of this BH member is 3 meters, right? We know this already. So I have to multiply it with 3, right? Similarly, this EY is producing the counterclockwise moment about that point O, so I have to write plus 8.25, and the perpendicular distance of this AY from that point O is this length OA, which is unknown, right? So I have to multiply it with OA. Similarly, this 2 kilonewton force is producing the clockwise moment about that point O, so I have to write minus 2, and again the perpendicular distance of this 2 kilonewton force from that point O is this OA, so I have to multiply it with OA. And this 4 kilonewton force is producing the clockwise moment about that point O, so I have to write minus 4, and the perpendicular distance or the moment arm of this 4 kilonewton force from that point O is the summation of OA, and this 5 meters are AB, right? So I have to write that this is OB length, and again OB is equal to OA plus AB, or we can write that this is OA plus AB length is 5 meters, so we can write it like this. So now OA is unknown, so first we have to determine this OA. So in order to determine this OA, we can use the properties of similar triangles, right? Now we have two triangles. We have OHB triangle. Let me write here that we have two triangles OHB, and we have OGC triangle. OGC triangle. Now we can apply the properties of similar triangles. So if I have this triangle, so we can write that this length, this is OB, divided by this length, and this will be equal to this length, this OC, since I am considering this triangle as well. So we have this triangle and this triangle, so this will be equal to OC divided by this CG, and this CG is 3 plus 2, so it is 5, right? So we have to divide it by 5. So now we have these two equations. So instead of OB, I can write this OA plus 5. So OA plus 5 divided by 3, and OC is equal to OA plus AB plus BC. So OA plus 5 plus 5, so OA plus 10. So we can write it as OA plus 10 and divided by 5. So now if we cross multiply this, if I cross multiply this, then this is 5 times OA plus 5 times 5, this is 25, and this will be equal to 3OA plus 30. So this, if I bring this A term to the other side, so this will be 50 minus 30, so this will be 20 OA. Sorry, this is 5 OA minus 3 OA. Sorry, this is not 50. This is 5 minus 3, so this will be 2 OA, and this will be 30 minus 25, so this is 5. So from this we get OA equals to 5 divided by 2, so this is 2.5 meters. So now this OA length is 2.5 meters. Now our problem is solved. We have HC unknown and OA unknown, and OA is now known, right? So we can write HC. I can take HC common from all of these, and again OB, if I write OB like this, so OB will be, OA is 2.5 plus 5, so this is 7.5 meters. So if I take HC common from this, so this will be HC, and OB is 7.5, so I can write it as 7.5 sine of 30.96 plus 3 cos of 30.96 plus OA is 2.5, so 8.25 into 2.5 minus 2 into 2.5 minus 4, and OB is 7.5, and this is equal to 0. So now when we solve this brackets, so this gives me 6.43, so this will be 6.43 HC. This gives me minus 14 0.375 and this is equal to 0. So from this equation we get Hc equals to 14.375 divided by 6.43, which gives me 2.24 kilonewton. Again, the sign is positive, so this means that the Hc force is the tension force, right? So now we have determined Bc force, Hg force and Hc force, which is the required solution of this particular problem. I hope you people would have understood this very important problem, right? So few people think that my videos helps in your learning, so do subscribe my channel and like all my videos. That will support my channel and will let me know that you people are taking interest in my videos.